first lesson. This is week 1 of your Flex Bridge. So Bridge, just so you know, it's just kind of an overall view of a lot of topics you've learned in your math career throughout high school. So hopefully most of this you have seen at some point. Maybe it'll look a little familiar, maybe not, but you should have everything you will need to be successful. All right, so today we're going to look at the vertex form of a quadratic function. This is in 2-1 of your Algebra 2 textbook. All content will be from Algebra 2. So our clear learning target today is I can identify key features of quadratic functions. So general thing about a quadratic function, it is a function is a quadratic function if its equation can be written in the form f of x equals ax squared plus bx plus c. We will talk more about this form in the next video. Today, so a couple things. All quadratic functions are transformations of the parent function defined by f of x equals x squared. So that's over here. That is just your most basic form. Notice your vertex, which is what we call is here at the origin, and it's just a straight up boom. And this shape here is called a parabola. All right. So the vertex form of a quadratic function is written as this: f of x equals a, these a's are the same, times x minus h. This minus h here is always going to be the x coordinate of your vertex, plus k. K is always going to be the y coordinate of your vertex. And that's just stated here, where hk is the vertex of the parabola. Vertex form is useful because it obviously, mathematicians aren't creative. It tells us the vertex. So we'll look at a couple of examples with that. A lot of this you are going to need a graphing calculator. I'll show you how to access that online. So it says, how are the transformations of the graph of f of x squared related to an equation representing another quadratic function? So what we're going to look at here is if we want to do f of x squared, what I've done is I've gone to desmos.com. Okay, so you're looking for this website here. I'm actually going to split screen this really quickly. Split view. So now we can see kind of everything we need. So in red here, and I'm actually going to turn off the green because we're just going to look at this g of x, which is a, and in red is our parent function, which is the blue. All right, blue over here on the right-hand side. So f of x is x squared. You'll see that's that basic one, and your blue. So what we can see is the first thing we should be able to notice here is that it is reflected over the x axis, all right? And so we took it, it was up top, now it's flipped over, and that is because of that negative sign here, right? Right there. That is what tells us it reflected. So our 1/2, it's kind of hard to see, especially this, but what it's done is kind of vertically kind of compressed. That's what that's done, that half. So we'll say it's a compression, vertical compression. And if you look here, you can see our original origin was at or vertex was at 0, 0. And now we've moved that 2 units to the left. So, and that comes from that there, that +2 tells us to move it 2 units to the left. So move 2 units left. All right. So that is for the blue one. So I'm going to turn that one off, and I'm going to turn back now my green, which is part B. So our red, we're still comparing it to that red one. So let's see. Well, we didn't reflect it this time because our leading coefficient here, that 2 is positive, but we did have what we call a vertical stretch. All right. So what we did is, since that number's bigger than 1, it is stretched our graph. Notice that stretch, it kind of looks skinnier, like you've pulled it up. Right, that green one specifically. So the next thing we're going to look at is our vertex. All right, let me zoom in here to click on. So the vertex is just this point here. So our original one was 0, 0. Now we have it at 1, -3. If you want to take a second, you may want to think, how does that 1, -3 as soon as I touched it, tapped off, relate to your equation or your function that's written. So maybe where do you see that over on the left-hand side? So hopefully you said, that you see that the 1 is right here and the -3 is there. So what we say is this was shifted left, shifted right 1 unit and down 3 units. Your first example should be that. So moved and shifted, you can think of those as kind of being the same thing. All right, so this next one here, this is example 2 on page 74 in your book, is what are the key features of a quadratic function? So the key features really just means, what do you see? Okay? And there's only 2 we're going to talk about here. So for this example, have given us the graph. You can also type this into desmos.com on the graphing calculator if you need it. But I just want to talk about the key features. So kind of like we did in the last one, we can see that our vertex from here is going to be 3, 4, right? So that's the vertex it gives us. The axis of symmetry, is this line that divides the parabola in half. Think of symmetrical, same on each side. So what we could say here is this axis of symmetry is this line x equals 3, meaning we're always going through 3 here. Now you may notice that the axis of symmetry and the x coordinate of your vertex, those are always going to be the same because this is the middle of the parabola. All right, so the last example we're going to do in this video, in this section, is example 5 on page 76. So it says the function g is in blue here, is a translation of the parent function f 1 unit left and 3 units up. What is the equation of g? So f, since it's what we call the parent function, or the most basic, we're talking about quadratics, it's just going to be x squared. So we know we moved g. We know we moved, or this, we need to think, how did we move it to get to g? This vertex, we moved it left 1, you can see that on the graph, and up 3. So the way that works here, so g of x, so your horizontal translation always goes inside the parentheses with your x. Think x is the horizontal axis, so your translation goes with the x. So we did go left 1. So that means, so since it's left, means you're going to do x plus 1. And then we went up 3. So it tells me to do a plus 3 outside. Just like that. So this is a little concept summary. It tells you about the vertex and how all of that moves from 0. You can find this on page 77. You can pause this video, or there's also a slide if you have the slides as well opened up. So there is one more video to go along with this assignment, and it'll be the next one. Thank you so much.